Let's work on example 2. This is a kind of reverse problem. We have a bunch of given conditions on function f, and we need to sketch a graph of such a function that satisfies all of these listed conditions. So let me start getting ready for this. We want to put all those conditions on a single graphing line. And let's see. So we have -4, +1, 6, 0 and 3 as the endpoints of the interval, so put -4, 1, 6, 0 and 3 in their right places, and then we start listing. So f prime is positive for x between -∞ and -4. So let me schematically put this vertical line and another vertical line here, and another vertical line there, and a third vertical line there, and the last vertical line here. So on each of those subintervals we're going to say something about the function. So first of all, the first derivative is positive to the left of -4 and between 1 and 6. Between 1 and 6, first derivative is positive. Secondly, first derivative is negative between -4 and +1, -4, +1, and to the right of 6, to the right of 6. Then second derivative is negative to the left of 0, so this is here and there, and between 3 and +∞. So 3 is somewhere here, it's starting at here and going up there. And then second derivative is positive between 0 and 3. So between 0 and 3 we put 2 plus signs. Now in total, what can we say? Between -∞ and -4, so let me put -∞ on this end. Between -∞ and -4, the function is concave down because second derivative is negative, and the first derivative is positive, so it's concave down and increasing. And this is the only way for it to work out. So it's concave down and increasing. Then between -4 and 0, the function is concave down and decreasing. So it's gonna be like this. Then between 0 and 1, the function is decreasing and concave up. So let me make it concave down and decreasing. And then it's concave up and decreasing, like this. Concave up but decreasing. And between -1 and 3, between +1 and 3, the function is concave up and increasing. That's this way. Then between 3 and 6, the function is concave down and increasing. So it's concave down and increasing. So this is the only way for it to go. And between 6 and +∞, the function is decreasing and concave down. So this seems to be the only way for it to work out. Now let me get rid of those green lines here, so that we see everything better. Okay, so that's the picture for this graph, and now we'll try to put all of that on a single sketch and see how that works out. So that's the small summary of everything that we did before. So let me restore the vertical lines between the intervals, like that. And so let's put the coordinate axis in, and I dashed all the lines. Okay, So let's see. You see this point -4, this -4, since function is increasing here and then it starts decreasing, so it looks like it is relative maximum. And then x equals 1 seems to be relative minimum, and x equals 6 seems to be relative maximum. At least we can make those. And then the point 0 and 3 are points of inflection. So I'll put pi next to them, because concavity changes at those points. So we can as well graph those on the coordinate axis. So let's say local maximum will be somewhere here, then inflection point is at x equals 0, local minimum at x equals 1, inflection point at x equals 3, and a maximum at x equals 6. Then we start connecting points. So to the left of -4, the graph should be concave down and increasing. So if it starts here, it should go like that, up to the maximum. So that's our piece of the graph. Then between -4 and 0, the graph should be concave down and decreasing all the way to inflection point, like this. Then between x equals 0 and x equals 1, the graph should be concave up and decreasing, reaching the minimum. And after that, it will be increasing and concave up to the inflection point. So let me have it like this. And then starting at x equals 3, the graph starts to be concave down but still increasing until we reach the local maximum, like this. And starting at x equals 6, the graph is concave down but decreasing, so it's gonna be going still down. And that, I guess, is my best interpretation of the situation. Okay, so this is the graph of y equals f of x. That seems to satisfy all the prescribed conditions.